We're going to look at algebraic expressions, multiplication today. But before we do that, let's look at a tricky example here of figuring out the difference, if there is one, of 2x squared minus 2x versus 2x minus 2x squared. There's a couple ways to look at this. For starters, we could look at, just think about our properties. If we had 5 minus 8 versus 8 minus 5, because this is subtraction, we think that changing the order is going to cause a problem. It is going to cause a change. So the commutative property is not present with subtraction. So already we're thinking, this can't be true. These things are not equal. But then, here's what gets strange, is let's practice. Let's say x is equal to 0. So we have 2 times 0 minus a 2 times a 0. By the way, this 0 is squared. And that's going to be 0 minus 0, so we get 0. Cool. And then here we have 2 times 0 minus a 2 times a 0 squared, and we get 0 minus 0, we get 0. So wait, hold on. I thought they were supposed to be different, because we knew the commutative property, and here's an example. But this one's the same? Okay, well, let's try a different one. What if x was equivalent to 1? So let's go through and look at that. So let's say x is 1. So we have 2 times 1 squared is 2 minus a 2 times a 1, so that's 0. 2 times 1 is 2 minus 2 times 1 squared, that's a 2. Wait, so it works again? Hold on, how is the commutative property suddenly working with subtraction in algebra? Is that what's going on here? Let's do another test. What if x is equal to 3? So we have 2 times 3 squared minus 2 times a 3. So we have a 2 times a 9 minus a 6. So we have 18 minus 6, so we get 12. Okay, now let's look at 2 times 3, that's 6, minus 2 times 3 squared minus 2 times 9, so 6 minus 18. Oh, we get negative 12. Okay, so when x equals 0 and x equals 1, it worked. It gave us a sense that these were equal. When we know that when x is not 0 or 1, they were not equal. So, in conclusion, be careful when you're testing using values of 0 and 1, because 0 and 1 can sometimes make expressions seem like they're equal. So that's the takeaway. Be careful when you use 0 and 1. They have a great power in them. Using numbers like 2 and 3 and negative 2 and 3 are often wiser and more effective. Also, rely on your knowledge of commutativity. You know that this order is changed. You know that subtraction does not have the commutative property, so you know there is a difference between these two expressions. All right, let's talk about the difference between multiplication and addition. In some ways, multiplication is that much easier because you just sort of smush everything together. Addition is sort of higher maintenance because you need like terms, whereas multiplication, I like to think of it as like you're just smushing everything together, like smoosh. So x plus x to the fourth, that cannot be simplified. The best way you can write that is x plus x to the fourth, or x to the fourth plus x. But multiplication, you don't need like terms, so let's just smush these together. I'm going to imagine that this is a 1 here. I'm going to add my exponents because it is the same variable. So I will get x to the fifth. Let's look down here. Like terms with addition are required. Like terms need to be the same variable to the same power. We do have the same variable, but not the same power, so these cannot be simplified. But with multiplication, I can multiply my coefficients. I'll get 6. And then I'm going to imagine a 1 right here. So it's an x times an x squared. So I have 6x cubed. All right. Negative 2x plus 3x plus 4x. Ah, they're all the same variable to the same power. So let's add them all up. Negative 2x plus 3x gives me 1 plus a 4x. So I should get a 5x. Now let's multiply. I'm going to multiply all my coefficients. I'll get a negative 24 and an x raised to the third power. All right, x to the fifth plus x to the fifth. Okay, same variable to the same power. Cool. So what I have is 2x to the fifths. Now x to the fifth times x to the fifth, I'm going to add my exponents, and I will get x to the 10th. Please be careful here. This is maybe a good one to remind yourself of. Sometimes I get kids giving me bad answers, such as 2x to the 10th. Blah. Please remind yourself that you only add your exponents when you multiply. And when you are adding, don't touch the exponents, right? Look, when you're adding, they're all the same. All right, now let's look at this one. X squared y plus x squared ya. Ooh, kind of similar. I'm kind of thinking they're like terms, but no, this is not the same term because this one does not have an a over here. So this cannot be simplified, but multiplication allows us to smush everything together. So what can be combined? I can get x squared times x squared, get x to the 4th. The y times the y gives me y squared, and then the a. Now, notice my technique of sort of either checking off or putting an underline under these, because that ensures that you keep track of everything and you don't forget a variable. And finally, let's look at x plus x plus x versus x times x times x times x. Did I say too many x's? I don't know. So this would be 3x, and this would be x cubed. Now, we're going to move on to doing a class notes number 2, but I'll do that in a different video.